This video will serve as an introduction to inequalities. I know you came to the internet to learn how to solve your homework, but this is going to be a more conceptual discussion. Um, Recently I had the experience where I got a little too lost in the sauce and I had to go back to first principles on some things. So I want to make sure that, we talk a little bit about what inequality is. So in the previous units, we've been working a lot with equations, okay? Equations. But now in unit 3, we're going to branch off. And equations are defined by having an equal sign. Now we're going to branch off into a new field or a new facet, which is inequalities, okay? Inequalities. And with inequalities, it is defined by signs like these. You may know them, let me clean them up a little bit. You may know them by the memory device alligators. Um, so in inequalities, we have those symbols and they represent a range of values, okay? And we're going to talk about what each of these symbols mean. And we're going to go through some examples. Whereas an equation is a single value. An equation will have a single value, and inequalities will have a range of values. For example, you may see x equals 5, and you may see x is greater than 5. These mean two very different things. On the right side, that means x is every number greater than 5. And on the left side, it means x can only equal 5. So again, this is going to stay, there's going to be no problem solving in this one. It's just a discussion about inequalities, okay? So let's scroll on down and let's define what each of these mean. We have this symbol, and we have this symbol, and then we have this symbol, and we have this symbol. What do each of these mean? Well, the first one is less than, less than. The next one is greater than, greater. We're just going to greater than, we're just going to abbreviate it. And then these are, well, these are less than or equal to. This may be a review for you, but it's going to be a review you need, equal to. And this is greater than or equal to, or equal to, okay? And when you see these, when you see something like x is less than, let's say 3, what this is telling you is that x is, if we mock up a number line here, number line, let's take it number line from here to right at the end of x. And let's say this is 3, and this is 2, and this is 1, this is 0, and this is -1, and it would continue onward. What x means with this expression up here, x is less than 3, means that x can be any value that is 2.99999 on and on, repeating, or smaller. Every number this way, 2, 1, 1 or a half, 1/8, so on. Every value, every real number headed in this direction, stretching on and on and on. Okay, so that's what that means. Now, when you let's say you add the or equal to sign to it. Now it changes. The only thing that changes is that it includes 3 now. Whereas it used to go up to 2.99 when we put this symbol, it includes 3. Okay. And now we could flip this sign. If we flip it to a greater than sign, well, now it's going to be, we have 4 and 5 and 6, and we're going to draw it right there as a open symbol. Yeah, we use an open symbol, which we'll go into further later on, but it just means that it's every number greater than 3. X is every number greater than 3. So X can't be 2 or 1, but it can be 3.1 or 3.01 or so on and stretching on and on. So that's what the big change is. You're not looking at you're not looking at a single value, you're looking at a whole range of values. And there's some real world examples of this. This is actually something that, will come up more often than you may think in real life, because you'll see stuff like, let's say, a height requirement, height requirement, height requirement. And this can be modeled. They say you have to be, you see your sign at the roller coaster place, and it says 48 inches. You see it at the amusement park, 48 inches. Must be this tall. You can model that, right? Let's say K for kid must be greater than or equal to 48. So that's saying if you're above 48, you don't have to be exactly 48. If you're 49 inches, well, welcome aboard. Let's take off. And you'll also see a real life requirement with like speed limits. You'll be driving down the road and you'll see a sign that says something like 65, speed limit 65. Well, this is telling you that your speed will represent with S must be less than or equal to 65, or you might get a ticket. Okay? And these types of situations pop up all the time. Let's add a little dude in here. Little dude. We'll add a little stick figure in here. He's just at 48 inches, we'll say. They let him ride. No worry. So these are some of the real life requirements where you're going to see, inequalities, and they model, specific things in the real world. Now you'll come to find that in this set of lessons, what we're going to learn. Well, what we will learn is solving. We're going to solve inequalities. We're going to graph them. And we're going to graph them on the Cartesian plane. And we're also going to graph them on the number line. We're going to do both of those. And we're going to, that's the big bulk of it. We're going to be solving them and graphing them. And you're going to see stuff like 3 is less than X and less than or equal to 10. And you're going to figure out, what does this mean? How do you graph this? How does it look on a graph? And stuff like that. That's just an example, but not a particularly good one. It would actually probably look more like, well, it doesn't matter, but you would learn to graph it, and this is just a random example, but you would graph it and it would be shaded in, and all of this would equal something and stuff like that. So we're going to learn solving, graphing them, how to apply them, and it's a little bit different than what you're used to. We're not going to come to one solution, we're going to come to a range of solutions. So I look forward to working through Unit 3 with you, and we'll get back into the next video with some specific examples and get you back to solving homework problems that didn't quite make sense in class. Thank you for joining me.